Shows the pressure and portions of a wave that fit into a tube. So here you go, and you know, because it's, well, after I told you that it was open on both ends, you should get something like this. Okay, so that's super easy. Then the temperature in the room is 104. What is the speed of sound? So V is 331 times the square root of 1 plus T over 273. But your T needs to be in Celsius. So you have to take, because hopefully you know that TC is equal to TF, minus 32, and then all over 1.8, something like that. So then 104 minus 32 becomes 72, and 72 divided by 1.8 is like 40?
Yeah.
Okay, so I'm just going to say 40 degrees Celsius to make my life easier. And so then I plug it up here, and what velocity you get for the speed of sound?
354.4.
354.4 meters per second. Okay, and then so, there you go, that's part B. Then part C, what is the fundamental frequency at which the air column vibrates? For an open-ended tube, hopefully you remember F is NV over 2L. So then we just plug in 354 over 2 times the length, and so that's 0.15, and then that gives you what? Okay, so 1180 hertz, just rounding off, and then part D, or part A4, I guess I should have called it. Sorry about that. So if a string, so we know that So we know that a couple of things. Beat frequency is equal to the difference in the other frequencies, right? The absolute value of the difference in the other frequencies. So the frequency of a string is 1 over 2L times the square root of T over mu. So what frequency does this come out to be? Oh, you don't know this. Just kidding. L is equal to 1 over 2F times the square root of T over mu. And then the frequency of the string, if this thing is vibrating at this frequency, then that means the beat frequency, if this is equal to 5, that means the frequency of the string is either 1175 or 1185. Yes? Yeah, remember beat frequency is when the two frequencies are really close together, you can hear a third frequency? Yeah, that's beat frequency. So you just subtract. So remember I said something like, if a tuning fork, we did this with Raymond. Yeah, he had his iPhone, and then we set both of our iPhones like 2 hertz off, and you could literally hear the wah, 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 that extra sort of sound. So that means all you do is take the two frequencies and subtract them, and just take the absolute value of that.
Is that an F?
So that's the definition of beat frequency. Huh?
5 or is that S?
This?
Yeah, S.
Oh, FS, for the frequency of the string.
Oh.
So, does it make sense to you that that is the frequency, or that's there? Okay, then take, what does this come out to be then? What length does that come out to be? Okay, and then so we took the tension, which is 55, divided by 0.0025, right? Because that says 2.5 grams per meter, but it should be kilograms per meter. So it should be the square root of 55 divided by 0.0025, and then divide that by, let's take the lower one, divide that by 2350. What do you get? 0.063 meters, which is